All right, guys, so today to get ready for this practice review session, let's first review our vocabulary and let's look at what this vocabulary looks like when we look at functions as well. So if we talk about our first term that we're going to review, the first term is a reflection. A reflection is a type of transformation. Reflection is when you flip over an axis or a point. So in this case, the function flipped over the x-axis or the point 0, 0. And if you see here, the first function f of x would equal x squared. That's the red line, the red parabola. The second function, which was a reflection of the first function, was negative x squared. So what you can see here is in our box, the negative in front of the x, that is what forced the flip or reflection of the function. So the next type of function that we'll review is when we do a horizontal translation of a function. This is when we translate the function to the right or the left. Remember that when you do this, it should be inside parentheses with the x, and whichever way you move, you're going to do the opposite with the x. So for example, here I said take away 3, and here I have positive 3. So the reason for this is if you actually solved this, you would see that you end up with positive 3 if you were to solve for 0. And that's the reason why. But again, horizontal translation, you're always doing the opposite, but inside of the parentheses with the x. The next translation or transformation that we're going to talk about is a vertical translation. This is when we translate the function up or down. For example, if we were moving the function x squared, that's our red line, and we moved it up 3 units, we would translate this by writing g of x equals x squared plus 3. The plus 3, that's by itself at the end. When you're talking about quadratics, you can think of this as the constant or the y-intercept. When you're thinking about this with linear equations, it's also the y-intercept. And that 3 or plus 3 at the end shows me that this function went up by 3, but nothing else changed. The last thing that we're going to review today is how to scale a function using an equation. Remember that scaling a function is when a function is shrinking or growing. So looking at this, one thing to remember is that if you're given a fraction or you write a fraction, it's going to make the function wider. So bigger might not be the best word. Let's change that to wider. And if the number is over 1, so not a fraction, or it could be a fraction, but just any number over 1, it's going to make it smaller. So if you look at my example here, the example is x squared, which is our original function, just like all of the other ones. But if you look at our scale, we scaled it by a factor of 3. And so what you can see there is that when we put the 3 in the front, and that's the place that you put a scale, it's going to make the function skinnier. So in this case, it made the function skinnier, and as I stated before, that number is over 1, and that's how we know that we're going to make it skinnier, or the word I used was smaller, but again, I think that skinnier is a better term for that.